Good day, Dr. Rushdie and everyone who's watching this video. Welcome to our presentation on the normalization of database schema. This project is presented by our team, Wong Jun Hoong, Cheong Jian, and Anbarasan Subramaniam. Let's dive straight into our findings. To begin with the background, this study focuses on the development and optimization of an academic management system. Our primary purpose is to create a system that efficiently manages and monitors various academic activities for a specific semester. Here we have the unnormalized schema, which serves as our starting point. We've captured the raw data into three main tables: lecture information, student information, and class performance. As you can see, specifically in the class performance table, the data contains repeating groups and blank cells, indicating that this is currently in unnormalized normal form. So, what is the actual issue with the unnormalized data? It creates data redundancy, where information is repeated, which leads to anomalies and confusing functional dependencies. The solution is straightforward. We apply a step-by-step normalization process, taking data from 1NF to 3NF to fully optimize the schema.
My name is Wong Jun Hoong, and I will continue to present about the first normal form. So, in order to convert the unnormalized table to the first normalized table, the following rules must be followed. The first rule is no repeated group in the table. The second is all data values are atomic. And the third is it has a primary key. And the fourth is if field must have a unicorn name. To convert the lecture information table from unnormalized form to the first normalized form, we introduce a new unit called school ID to uniquely identify institution unit. And for the student information table, we maintain the atomic attribute and we introduce a semester attribute to uniquely identify each enrollment period. And for the class performance table, we introduce a program ID and remove the duplicate record to ensure each student class pairing was unique. And the table will continue to become a second normal form. And same as previous, they also have a 4 rules need to be followed to convert the first normal table to the second normal table. The first rule is it must have first in the first normal form. And the second is the all non-key attributes are dependent on all part of the primary key. And the second is same, the table must have a primary key. And the fourth is also same, each field must have a unicorn name. The first is the lecture information table. To convert the lecture information table from the first to the second normal table, we eliminate the partial dependency by splitting the data into the three entities. The first entity is the lecture table. It is about the lecturer information like name and email. And the second table is the lecturer information table. It's talking about the lecturer is belong to which school. And the third is the school table. It's talking about the school and the faculty name. And for the student information table, to remove the partial dependency, we're also splitting them into the three entity. The first is the student table. It's about the academic info depend on the student ID. And the second is the student information table. It's showing about the student is in which semester. And the third is the semester table. Is about the enrollment date and also the year. And for the class performance table, to remove the partial dependency of the table, we decompose the table into the three unit, the three table. The first is the class setting. It's talking about the schedule, the timetable of the class, and the lecture assignment. The second table is the class detail. It's talking about like the what the course is belong to which faculty, the core ID and something else. And third is about the class performance. It's talking about the student mark and student attendance.
I'll show you how we structured our database into third normal form to keep everything clean, consistent, and scalable. A third normal form database means it's already second normal form, and no none column depends on another none key column, and there is a primary key in every table, and every column has a unique name. Next is lecture to information table. So we split lecture data into three simple tables, which is lecture table, school table, and lecture info table. For lecture table, there is a lecture details in the tables, and for school tables, there is a school and faculty infos, and for lecture info table, there is a links lecturers to their schools. And this structure was already in third normal form, so no changes needed. Okay, next will be the student information table. So we organize student data into five focus tables. So there is a student table, which is there's a personal info about students, and there is a grade table for academic performance, and next is semester table for enrollment timelines, and online class table for grading rules, and student info tables for linked students to semesters. Fifth, we fixed the honors depends on the CGPA issue by separating them. Okay, next is class performance table. Class data was split into three tables to avoid sensitive dependencies. And for class sitting tables, it stores when and where each class meets, and which lecturer teaches it, and which group A or B or etc. is attending. So each row is a unique by class code plus group, and no non-primary key column depends on another. Next table is class details tables. So it stores basic class info, which is name and related program ID, and links each class into specific academic program, and only contains details directly about the class and no extra info about the program or school. Here. Next table is program table. So there is a list of academic programs and their schools. For an example, information technology belongs to SOC. So it prevents repeating program or school info across multiple classes. And the last table is class performance tables. It stores individual student performance in each class. For an example, carry marks, attendance, and exam eligibility. Each row is a unique per student and class, so with no density dependencies. Okay, why we split the tables? Because uh, before we split the tables, the classes details including program and school info, so repeated data, it will repeated data. Once we get Once we split the tables, the program and school move to separate tables, and there is no repetition and easier updates. So the benefits of the split the tables are cleaner and more efficient and avoids the data inconsistency. So to bring it all together, we successfully normalized our academic database through a structured three-step process, which is in first step. In first normal form, we made all data automated by ensuring each field contained only invisible values. Then, in second normal form, we eliminated partial dependency so that every non-key attribute fully depended on the primary key. And for the final is in third normal form, we remove sensitive dependencies by ensuring no non-key attribute dependent on to another non-key attribute. The result is a cleaner, more reliable database that eliminates redundancy, prevents data anomalies, and is easier to maintain and and scale for future needs, ensuring long-term data integrity and system efficiency. That's all from us. Thank you so much.